Hello everyone. Today I will discuss about work and friction. So to discuss about what is the work, so let just I'm putting this remote on my palm. So until and unless I am applying some force on this remote, it doesn't change its position. But while I'm applying some force on this remote, then it displaces from one position to another position. Then we call the work is said to be done. So what's the definition, exact definition of work done? When some force is applied on a body and the body displaces through certain displacement and the force has a component along the displacement, then we call the work is said to be done. And mathematically, we can also represent work as force into distance. That is, W is equals to Fs, force into distance. And we can also represent work done in terms of the dot product. That means while we are taking the dot product of force and the displacement, we can also get the work done, that is W is equals to F dot S is equals to Fs cos theta. Just see, this is your force, this is your displacement, making an angle theta between them. As we know the resolution, suppose we are splitting this force according to the resolution, then this F having a component along the displacement which is your F cos theta. So here we have put this F cos theta. So the work done is equals to Fs cos theta. So there may be a question in everyone's mind, though it is a dot product of two vector quantity, so why it is work done is a scalar quantity? It's a very important question. So while we are doing some work or while we are calculating the amount of work done, it is doesn't matter upon the direction, only depends upon the magnitude. Since it is only depends upon the magnitude, 12 joule work, there is no requirement of direction. That's why work done is always a scalar quantity, though it is the dot product of two vector quantity. Just see how much work is done by a force of 10 Newton in moving an object through a distance of 1 meter in the direction of the force. It's a very tricky question. So we have to calculate what is the amount of work done. So what is the formula? As we know, the work done W is equals to force into Newton. So in case of force, I have put 10 Newton and the body displaces through 1 meter. So the distance is here 1 meter. So 10 Newton into 1 meter, which is equals to here 10 joule. So the amount of work done is here 10 joule. So here we conclude that there is no direction, no such direction towards east, towards west, towards north, towards south. That's why we again conclude that work done is absolutely a scalar quantity. Now we will discuss about types of works. The work is basically divided into three types of. That means your positive work, negative work and zero work. So what is positive work? That means depending upon the angle between the force and the displacement, the work done is classified or the divided into three parts. So first of all, we discuss what is your positive work. So here the angle between the force and the displacement is 0 degree. When the angle between the force and displacement is 0 degree, the cos theta is equals to 1. So the work done is equals to Fs. As the formula W is equals to Fs. As the formula W is equals to Fs cos theta, and here my cos theta I'm just moving to the next slide. Here so theta is 0 degree, so cos theta is equals to 1. So now I am writing I'm adding the pen, just wait. Okay, so here theta is equals to 0 degree, cos theta is equals to 1. That's why work done is equals to Fs. So Fs means your positive work. So why it is positive work? Because according to definition of positive work, the work done is said to be positive when the direction of the force and the displacement are along the same direction. That means the angle between them is 0 degree. That's why it is a positive work. So let's we discuss one example of a positive work. Suppose any person lifting a box in a vertically upward direction. So the person applying the force in vertically upward direction. So when the person applying the force in the vertically upward direction, what happens to the displacement? The displacement is also in a vertically upward direction. That means the force and the displacement both are along the same direction. That's why it is a positive work. Now we move to the next one. Negative work. So when the angle between the force and the displacement is 180 degree, 180 degree means they are just opposite in the direction. When theta is 180 degree, the cos theta is equals to minus 1. So the work done W is equals to minus Fs. Minus means it is a negative work. So what do you mean by negative work? The work done is said to be negative when the direction of the force and displacement are opposite in that direction. They're just opposite in that direction. So now we just take one example of a negative work. All the work done by the gravitational force. Suppose anyone lifting a box in a vertically upward direction. So when anyone lifting the box in vertically upward direction, the weight is acting in a vertically downward direction because the gravity attracts towards the center of the earth, which is the downward force and which is the negative force here. That's why all the work done by the gravitational force is a negative work done. We also take another example of the negative work. Suppose a bus is in motion or a vehicle is in motion. So while the vehicle is in motion in a forward direction, so after some time the driver applied the brake. So when the brake apply, the direction of the motion and the direction of the brake just opposite to each other. That's why it is also a negative work. Now we move to the next one. Zero work or no work. So what's the condition for the zero work and the no work? The angle between the force and the displacement are perpendicular to each other. That means theta is equals to 90 degree. When theta is 90 degree, our cos theta is equals to 0, and when cos theta is 0, W is equals to Fs cos theta. Cos 90 is 0. That's why my work done is 0. This is known as your zero work or no work. So now we take an example of a zero work. Suppose a coolie is carrying a box on her head and moving in a forward direction. So while the coolie is lifting a box or anything luggage, anything in a vertically upward direction and then carry the luggage in his or her head, then move, then what happened? The direction of the force and the applied force and the direction of the motion just perpendicular to each other. Since they are perpendicular to each other, the work done is 0, which is known as your zero work or no work. Or someone lifting a plate in vertically upward direction and then move. That means the direction of the force and the displacement are just perpendicular to each other. That's why it is also one example of a zero work or no work. Or simply suppose someone push a wall. When someone push a wall, there is no motion. As we know, what is work? Very simple definition. Work equals to force into displacement. Since there is no displacement, in case of displacement, we just put 0. That's why it is also example of a zero work or the no work. So these are all about the types of work. Now we discuss what is the dimensional formula of work. So what is dimensional formula of work? As work is the product of force into displacement. Work is the product of force into displacement. So the dimensional formula of work, W is equals to, first we put the dimensional formula of force, which is your mass into acceleration. That's why m1 L1 t to the power minus 2. Then we put the dimensional formula of the displacement. As the distance and displacement is a fundamental quantity, that's why it is simply represent the length. And finally, the dimensional formula of work is equals to m1 L2 t to the power minus 2, which is the dimensional formula of work. So now let's discuss what is the SI unit of work. As we know from the formula, what is work? Work equals to force into displacement. So first we put what is the SI unit of force. So what's the SI unit of force? The SI unit of force is your Newton. So work equals to 1 Newton into the SI unit of displacement is your meter. So 1 Newton into meter, which is equals to your 1 joule, which is the SI unit of work. Similarly, we discuss about the CGS unit of work. So first we put what is the CGS unit of force. The CGS unit of force is your dyne. Then we put the CGS unit of displacement, which is a centimeter. So dyne into centimeter represent our arc. So the CGS unit of work equals to your arc. So now we find out what's the relation between the joule and the arc, which is a very important relation between the joule and arc. As we know, what is 1 joule? 1 joule means 1 Newton into 1 meter, and 1 Newton is equals to our 10 to the power 5 dyne, and 1 meter is equals to your 10 to the power 2 centimeter. So finally this is equals to 10 to the power 7 dyne centimeter, where the dyne centimeter represent or, that's why 1 joule is equals to 10 to the power 7 arc. This is a relation between the joule and the arc. So these are all about the work. Now I move to the next part of this chapter, that is the friction. Friction is very important, because without friction, I am walking here, I am holding this remote, and I am writing here. So all these things are only possible due to friction. If there is no friction, then I am unable to write, I am unable to work, I am unable to hold this thing. That means the friction is required. That means most of us, we just think that the friction is harmful to us. No, the friction is not only harmful to us, it is also required, because without friction we can't walk, we can't write, we can hold the things, all these things. So we discuss what is a friction. That means friction absolutely a contact force. When a body moves over another surface, then what happens? A force develops. When one body over another surface, then a force of friction develops, or this is the opposing force, which is known as the force of friction. And since there is requirement of two body or the two surface, that's why we can say the friction is always a contact force. And as I already said that when a body moves over another surface, the force which opposes the motion of the body, we call this is force of friction. That means the direction of the applied force and the direction of the frictional force is always opposite in their direction. Since one body moves over another surface, that means it obviously depends upon the nature of the two surfaces in contact. That means if the two surfaces are the smooth, the friction is very less, and if there is a roughness between the two surfaces, the friction is high. And as I already said, that means when a body moves over another surface, then we call it is a force of friction. That means it is always acts parallel to the given surface. It moves over another surface. That means it always acts parallel to the given surface. There are various factors. That means the factors depends upon these two factors are depend on for the friction. So what are the factors? The roughness of the surface, which I already discussed. If the two surfaces are the smooth, then the force of friction is less, and if there is a roughness in the surfaces, then the force of friction is high. And another thing is the force pushing the surfaces together. Here I am applying some force, that means now I am applying some force. Now the force of friction is less, but while I am applying the forces in a very high manner, then the force of friction is very high. That means absolutely clear that the force pushing the surfaces together, because there is a contact force. Friction is contact force, so it is pressing the two surfaces together. Now let's move. Just see, this is in this figure it is clear that the applied force and the frictional force just opposite in that direction. This is the direction of the applied force, while I am applying force in that direction, and the frictional force are always opposite to the direction of the motion. That means it opposes the motion. That's why the applied force and the frictional force are always opposite in that direction. And just see here, the weight of the body or weight of the box, this is a box, the weight of the box is acting vertically downward, and what is weight? Weight is equals to mass into acceleration due to gravity. And just watch here, this is a normal reaction which is represented by a symbol of R. So what is that normal reaction? Just while this is a weight of the body is acting vertically downward, this weight of the body balances by another force. The force which is acting perpendicular to a given surface and the balances the weight of the body, which is known as the normal reaction, which is denoted by a symbol of R. And while we are solving the numericals, you can put in case of R is equals to mg, since the weight of the body balances by the normal reaction. Now we discuss what are the types of friction. There are actually three types of friction. One is a static friction, then your limiting friction, then your dynamic friction. So what is static friction? Just see, I am holding a remote and I am applying some force. Is there any motion right now? Is there any motion? No motion. Why there is no motion? Since I am applying some force. I am applying some force means obviously there is some frictional force, but the body doesn't change its position. That means the body is in a static condition. So this type of friction is known as a static friction. Since there is friction but no motion is there, this is static friction. That means suppose I am applying 1 Newton of force, but the remote exert a force greater than my applying force. That's why there is no friction, there is no motion. This is static friction. So while I am applying a little force more than the static friction, then what happens? The remote start motion. So when the remote start motion, that means at that time the static friction changes to another type of friction, and we call this is your limiting friction. That means the body at the point of motion, just motion start. So this type of friction is known as a limiting friction. Otherwise, we can also say the maximum value of static friction is known as the limiting friction. Maximum value of static friction is also known as the limiting friction. Now we move to the dynamic. Once the body is in motion, then what happens? The body continue its state of motion. When the body continue its state of motion, the friction is known as a dynamic friction. So otherwise you can say the force of friction between the body and the surface, so long as there is a motion, is known as the dynamic friction. Basically three types. One is static, limiting and dynamic. So just watch here. This is my graph. This is the applied force in a x-axis, and I am taking the frictional force in a y-axis. So this region, this red region is known as a static region. That means static friction applied here, static no motion. The body is at rest condition. And just see in this portion, this is a green portion which is limiting. That means at that point the motion just begin. So this friction is known as a limiting friction. Then the body is in motion, that means continuous motion, which is known as a dynamic friction. So this is a static region, static friction. This is your limiting friction and this is your dynamic friction. Then we discuss what are the laws of limiting friction. The laws of limiting friction is very, very important. So what are the laws? The laws of limiting friction states that the force of friction depends upon the nature of the two surfaces in contact, which we already discussed. It absolutely depends upon the nature of the two surfaces in contact. And the force of friction always opposes the motion of the body. From the very beginning, we just know the applied force and the frictional force are opposite in that direction. That's why it always opposes the motion of the body. And since one body moves over another surface, that's why it always acts parallel to the given surface, which is the third point. The force of friction always acts parallel to the given surface. Then what is the next point? The force of friction is directly proportional to the normal reaction. Directly proportional to the normal reaction, that is F proportionals to R, that is F is equals to mu R. So what is that mu? This mu is known as the coefficient of friction between the two surfaces, where mu is known as the coefficient of friction. Coefficient of friction between the two surfaces. So these are the laws of limiting friction, and while we are solving the numerical in case of R, we have to put R is equals to mg also. So now we discuss what is coefficient of friction. What is coefficient of friction? So from the laws of friction, we know that the force of friction is directly proportional to the normal reaction. That means F proportional to R. So from this expression, we can get mu is equals to F by R, where the mu is known as the coefficient of friction. So what's the definition of coefficient of friction? The coefficient of friction is defined as the ratio between the force of friction to the normal reaction. That means mu is equals to F by R. F is the force of friction and R is the normal reaction. So what's the unit and dimensional formula of the coefficient of friction? So what is F? F is the force of friction. That means it is the opposing force. What is R? R is the normal reaction. That means perpendicular force. So simply it is a ratio between the two forces. That's why the coefficient of friction is a dimensionless quantity. No unit and no dimension. Coefficient of friction is a dimensionless quantity. Yes, she. A body of mass of 10 kg is moving over a rough horizontal surface, and if the coefficient of friction between the body and the surface is 0.1, then we have to calculate what is the force of friction between them. So what is the given quantity here? The mass is given, the mass is 10 kg is given, and the coefficient of friction between the body and the surface, which is 0.1, is given. So we have to calculate the force of friction. What's the formula? F is equals to mu R. So F is equals to mu. In case of R, we have to put mg, mass into acceleration due to gravity. So mu is a 0.1, mass is a 10 kg, and the g is a 9.8, which is equals to your 9.8 Newton. So this is the force of friction between the body and the surface. Now we just discuss what are the methods to reduce the force of friction, because sometimes the friction is also very harmful to us. The friction is not always helpful to us, it is also harmful to us. That means due to the friction in a machine part, it produces the wear and tear, so that the machine get damaged. It also produces the unnecessary heat. It also produces the noise, and there is a loss of energy also takes place. So to minimize this thing, actually we can't make the friction is nil. That means we can remove the friction 100%, but we just try to minimize the force of friction. That's why we are just there are various methods to reduce the force of friction between the two surfaces. We are discussing about a very few methods. So what are these methods? The first method is by rubbing or the polishing the surfaces, and by using the lubricants, that means oil and grease is another method. By using these things we can also reduce the friction. Then another thing is by decreasing the area of contact. By decreasing the area of contact, we can also reduce the force of friction. And by streamlining, we just discussed these 4 points. So first one is by rubbing or polishing the surfaces. While we are moving a park, there is a slider is present. So all of us should see that the slider surface is very smooth. Why this is smooth or polished? Because when children are going to there, they can slide easily. As it is very smooth, there is the force of friction is very less, so that they can easily slide. This is one method. Similarly, someone is two friends are start riding their bicycle. Someone riding in a smooth road and someone riding in a grass field. So the force of friction is less in case of the smooth surface, so that the boy can easily ride the bicycle. And in a grass field, what happens? The force of friction is high. That's why it is little bit difficult to ride the bicycle. That's why this is a one method. By polishing the surfaces, we can reduce the friction. Then by using the lubricants, it is the finest method to reduce the force of friction, by using the oil or the grease. So what happened? Actually, there are in the two surfaces there are some irregularities are present, or the interlockings are also present. So while we are applying some oil or a grease, then the thin layer of oil spread over the surfaces, which reduces the force of friction. Actually, what happens generally when we open, that means when we open the door, might have seen door close or open the door, there's some noise is coming. So to avoid this noise, what we are doing, we just put some oil there. That means on the hinge we just put some drop of oil. So after few hour it will smooth the surface, so the noise is also reduces. It is also one method. Then suppose someone is now we discuss the third method, that means by converting the sliding friction to rolling friction, or to reduce the area of contact, this one. So while someone is sliding a heavy luggage, it's very much difficult to slide a heavy luggage on a road or on a surface. But if we use the wheels on this luggage, then what happens? The area of contact decreases. That means we just convert the sliding friction to rolling friction here. The area of contact decreases and we can slide this luggage smoothly. So it is also one method to reduce the force of friction between the two surfaces. And by last one is by streamlining. So what do you mean by streamlining? That means the shape is sharp or the pointed. While we are writing the pen, all of us just see the shape of the pen is pointing. Why this is pointing? Because if the shape of the pen is blunt, then we are unable to hold this pen easily, because the area of contact is very high since it is pointed, so that we can hold the pen easily and we can write also smoothly. So this is known as a streamline. And the shape of the jet, aeroplane, all are the streamlining, that means pointed, because it is also reduces the force of friction. So these are the methods to reduce the force of friction. Thank you.